G'day everyone. What we're going to be doing in this series of videos, and there's going to be a lot of videos based on the same concept, is something that occurs every day, yet we don't realistically think about it, and it's called the latent heat of change. And now it relates to, like I say, a lot of everyday effects, and we're going to cover a lot of examples as to how those and what those effects are as we go through the series of videos. But what we mean by the latent heat of change is the fact that when a substance changes its state, it consumes a huge amount of heat energy. And in doing so, that is called the latent heat of change, and it's calculated using water. So the fundamental understanding of understanding what happens when you get 1 gram of water, it consumes 80 calories of heat energy to change from a solid into a liquid. So if we got 1 gram of water, it's going to absorb 80 calories of heat energy to change it from 0 to 0, but from ice to a liquid. So that's a huge amount of heat energy that has been doing nothing more than changing the state from a solid to a liquid. But then it takes 100 calories of heat energy to absorb, change that water from 0 to 100 degrees Celsius. And that's a measurable thing. We're going to be doing the experiment to see, and making sure these calculations aren't just a myth, they're actually realistic, and they are. I've done this many times over the years for training apprentices, but it's a good way of understanding how air conditioning systems work, because this same process happens inside air conditioning systems. The second state of change that takes or occurs with our water is when it gets to 100 degrees Celsius. So it gets to 100 degrees Celsius and it changes from a liquid into a vapor. But in doing so, it absorbs 540 calories of heat energy. That's 5.4 times more heat energy that it was used just to get it from 0 to 100 degrees Celsius. So we're going to be doing the experiment in this pot, and other experiments as we go through, and other things that we were talking about before, and everyday examples as to where we see this rate of change happening in air conditioning systems. The weather, we're going to be doing a video on how hygrometers work at the Bureau of Meteorology that can calculate the humidity and understand the relative humidity of the atmosphere. And they've also got a thing called feels like, so it might be 20 degrees Celsius, but they'll also, it feels like 16 degrees. And we're going to be understanding, by the time I get this series of videos finished, how those different things occur. But what we're going to do with the first video is we're going to change the state of water from ice to turn it into liquid. Okay, I'm back, and we've just measured out 500 grams, half a litre of ice. So we've measured it precisely. It's 503, but that's near enough. And I'm going to put that into this pot, and I'm going to put that pot onto a burner. The burner's going. I've got an LPG burner, so we can actually see the process instead of using the stove. So I'm going to set the timer as soon as I put that on there. So bang, time is set. And what we're going to do is we're going to time how long it takes for that ice to turn it into a liquid. And then we can use that as our starting point down here. We'll use that as a reference. And as we go through this, process, you'll see that all these measurements do actually coincide. Like I say, I've done this experiment many times, and they all seem to work out pretty close. So we know that that ice is now melting and turning into water. Another part of the experiment that I want to cover is to get ice, and I'm going to put that ice, and I'm going to put that into a container. So I'm just going to get a container of water out of the fridge. So this plastic bag of water, I have just got it filled with a little bit of water, and I'm going to sit that in there. And I've got some crushed ice here, and I'm going to put that into the container. I can go over there. And what I'm going to do is, now what's happening with our ice that's on the burner here is I'm holding my finger in there, and that's still really cold, still 0 degrees Celsius. So the ice is melting, and that's been coming up to 2 minutes. With this container, I'm actually going to pour a lot of salt onto the ice. And the reason for this, what I'm doing is, or what I'm trying to achieve, is showing or replicating two things. One, the fact that in parts of the world where you've actually got a lot of ice, they put salt on the road to melt the ice. But something also occurs when that happens. The latent heat of change from that ice melting absorbs a huge quantity of heat, or huge quantities of heat energy, and we're going to see another effect that's going to happen as we're going through this. That water still, I can hold my finger in there, and we can see we've got condensation building on the side of our pot. So that's still 0 degrees Celsius, still cold, icy cold. The ice is still melting. We're coming up to 3 minutes. It generally takes around about 3 minutes and 40 seconds. So I don't think we're going to be too far off the mark. The next thing we want to cover, and I don't want to get too carried away because we only got 20 seconds to go, and I reckon it's going to be about right. There's very little ice left, and that's 3.5 minutes, and the water temperature is just changing. So yeah, we'll say 3 minutes and 40 seconds. We'll stop that and restart it again. And what we want to do now is we want to time, yes, that water's just getting a little bit warmer now. We want to time how long it's going to take to get from there to 100 degrees Celsius. So from 0 to 100 degrees Celsius, we want to have that time frame. We know we've got 3 minutes and 40 seconds to change it from being a solid into a liquid, and we want to see how long it's going to take to get it from 0 to 100 degrees Celsius. What I'm trying to do in this little experiment here, is show you the process of what another area where it used to be used is on fishing boats before the introduction of really efficient air conditioning systems. When I was a kid, they would always talk about putting salt on ice as a slushy to freeze the fish. It was something that always intrigued me, and the reason why they do that is the fact that they are changing the state of the ice to turn it into a liquid, but it has to absorb heat from somewhere. So that container of water that we put in there is not frozen, and what they're doing is they're extracting the heat from that water, and what we'll do is we'll see a change of state. We should see that plastic bag when we get close to our boiling point for water. We should see that little plastic bag that I put in there turn into ice. We'll wait. This is going to take around about 4 minutes, and we're not going to wait that long, so I'm going to pause the video there. We've done 1 minute 50 seconds, so we'll come back closer to 4 minutes. Okay, we're back. The water's coming up to 4 minutes, and we're just starting to get into a uniform boil. So we'll cut that off there, and we'll start the timer again. And what we're going to be measuring now is how long the water takes to get it from 100 degrees Celsius to 100 degrees Celsius, but it's changing the state from liquid into a vapor. And that takes 5.4 times greater in terms of time frame to change it from a liquid into a vapor in comparison to our water changing from 0 to 100 degrees Celsius. That's a huge amount of heat energy that has been absorbed to change the state from a liquid into a vapor. Now, we've got half a litre, we've got 500 grams of water that we initially started off with, and we want to sort of verify the fact that this calculation is going to work without burning the pot base. We know based on that theoretical concept that we should be able to boil the water for about 25 minutes. We're not going to do that. We want to halve that time, and we want to drop it down to, when I do the calculations, we want to be able to boil the water for about 11 or 12 minutes, and then what we're going to do is turn the burner off, and we should be able to measure that volume of water inside the container, and it should be half of the existing measurement. So we're going to let that keep boiling, and when we get closer to the end, we'll stop the timer, and then we'll measure how much water is, or how long it's taken to actually, or what volume of water we've actually got. Now, we'll also have a look at that experiment there. That should have turned into ice by that stage. Okay, it's 10 minutes, we've got a minute to go, so I thought I'd come back. One thing I found quite interesting is the fact that I was watching this before, and as I was spraying the salt on there, just have a look at the flames. So the flames are getting some of the sodium chloride as I'm putting it into the air. You wouldn't believe that something would travel so far, so fine. Just goes to show you don't know what's in the air. But anyway, that's 10.5 minutes. Like I say, we started with 500 mils of water. Our time frame for our 4 minutes been multiplied by 5.4 gives us roughly 22 minutes. So we should end up with roughly 250 mils if the calculation works. And if it's out a little bit, then it's going to be out a little bit, not much though. Like I say, I've done this experiment many times over the years. And we're not in a laboratory, we're basically in the kitchen sink, and so we should end up with 250 mils. And I'll tell you what, that is brilliant. That is 250 mils. Pretty much on the dot, which reinforces the experiment and the calculation. It reinforces the fact that the calculation is correct, and saying that it took 80 calories of heat energy to take it from 0 to 0. It's just changed the state from a solid to a liquid. It took 100 calories of heat energy to get it from 0 to 100 degrees Celsius. Then it took 540 calories of heat energy to change it from a liquid into a vapor. Now, we only took 4 minutes to get it from there to there, so 4 multiplied by 5.4 is roughly 22 minutes. So if we halve that, which was 11 minutes, which is what we did, and then re-measured the fluid, we ended up with 250 mils, which is half of our original volume. So it's a good little experiment to show how the latent heat of change absorbs a massive quantity of heat energy. Now, if we refer back through to our a similar system in comparison to what we're doing when we're changing the state from ice to turn it into liquid, we had a flame on the burner that was being used to change that, or to allow that heat energy to be consumed. We never had anything on when we put the ice into this container here. We put a container, plastic container with water in it, and that energy has been absorbed by that latent heat of change, as that is now changing from solid into liquid. Now we can see that is turned into ice around the condensation is developed, and that condensation is now changed into ice through that latent head of change from the salt inside the container. Now if we pull this container out, that should have turned into ice, and it has. So there's another little part of an experiment that has worked, that's turned into solid ice, and that's just going to show another aspect of our latent head of change. And that is going to be, as you'll see with further videos that we do, quite an interesting thing to understand when you understand how air conditioning systems work, how humidity plays a massive part in our ability to actually stay comfortable. But at this stage we'll just finish it with that, and we'll start the next video.